Here's a ratio test in 60 seconds. So the ratio test looks at the ratio of the current term and the next term until n goes to infinity. And what we're looking for is, are the terms getting smaller as n goes to infinity? I'm going to refer to this limit as L, and depending on the value of L, there are three scenarios that could occur. First off, if L is greater than 1 or the next term is bigger than the last term, that means the sequence goes to infinity, so the series must also go to infinity or diverge. Now, if L is less than 1, that means the next term is always smaller than the previous term, so the sequence goes to 0 and the series converges. And if L equals 1, the ratio test is inconclusive. Now we're going to use the ratio test to see if the series n squared over n factorial converges. So I have my limit, the n plus 1th or next term, and the nth or the current term. Here I'm going to rewrite, so instead of dividing by n squared over n factorial, we're multiplying by n factorial over n squared. And then I'll use factorial properties to separate this into this. As you can see, the n factorials will cancel, which leaves us with this limit. We can see that on the top, if we multiply this out, it'll be a power of 2, but on the bottom, if you multiply all this out, it'll be a power of 3. So since the bottom dominates the top, this limit goes to 0. Since 0 is less than 1, we know this converges.